Let's take a look at this problem now. It says, inscribe a right circular cylinder of height h and radius r in a cone of fixed radius big R and fixed height big H. See the illustration. And then it says, express the volume V of the cylinder as a function of R. Hint, V equals pi r squared h, which is the volume of a cylinder. And it also says, note also the similar triangles. So what we're going to start first is there with their hint. We're just going to take V equals pi r squared h. And what we're going to do with this is we're going to now take their second hint. And their second hint says, hey, note also the similar triangles. So take a look at this. If I draw this in here, I can see the similar triangles they're talking about. So the first one is this triangle here. And then the second triangle is when I create it, it's the one I see here. That's the second one. So what we're going to do is I'm just going to draw this below. So all I put in here so far was big H and big R. I want you to see those. Now those are given. We understand those. Now what's going to happen in here is, here we have little r. Now here, what is this distance? Now that's a distance that we're going to need also. So let's think about it. If I went all the way, that would be h. Okay, big H. I got to be careful because I got a little h too. And if I look at my drawing up top here, this right here, from here to here is little h. So that's this piece down here. That piece down there is little h. All right, so now we're going to take a look at what this would be. So if the whole way is big H and the little way is little h, that piece there is actually going to be big H minus little h. And that's what this piece is in here. So I'm just going to draw it in there now. So now I have everything I need to use this idea of similar triangles. So now I'll take the bigger triangle and take its dimensions. And remember, when we're dealing with similar triangles, we have corresponding sides. So there's a proportional relationship there. So I can say we have big H over big R, and that's going to be equal to this side here, because that corresponds to big H. So that's going to be H minus little h, and that's equal to little r. I shouldn't say it's equal to little r, but I should say over little r. Okay, and the r should be on the bottom because this side here corresponds to this side here, so that's why they're set apart from each other that way. Okay, so that's our design here. That's our setup. Now again, keep in mind here, it's said in the problem itself that R is fixed, and it also says that H is fixed. And that simply means there that they're just treated as a constant since those are variables that are fixed. Okay, even though they're variables, they don't change anymore. It's just they're that number and that's what it is. So it's like if I had the number 3, I would say, hey, it's the number 3. So H is the number H, big H, of course. And then big R is just the number big R. So it's treated as a constant here, even though I have a formula or with variables. The only variables I have here are little h and little r, because those can change. All right, so now we're going to solve this thing for little h. Now we're going to solve it for little h because then when I plug it in here, I'm going to end up with r's if I solve it for h, because I'm going to take that h out and put everything else in place of it. So that's what confuses people sometimes a little bit, is the fact that, oh, what do I solve for? You know, I want to solve for r since I want a function of r. No, you're actually going to solve for little h so that when you plug it in, you get a function of r. Okay, so anyways, so let's work this out then. So this is going to give me, first I'm going to multiply both sides by little r, because those are going to cancel then. And that's going to give me r big H over big R, and that's going to equal h big H minus little h. All right, cool. Now I'm going to subtract big H from both sides. Now I'm going to show all these steps because it's all letters. And I know this has to be horrible for some people. They have a hard time with letters. So RH, oops, let me fix my H there, minus, oops, not minus yet, over R minus H equals negative H. So then I'm going to divide by -1. So I get H minus R over H over big R equals H. So that's what it equals. Now I don't know if the book's going to want this, but I can put those together. If I take this first one, I can think of it over 1. So I got to multiply the top and the bottom by R, and then I can. I'm not sure what they're going to do here, but I can put those together as well. And they will. Just because that's what I think they would want, to be honest with you. So then my final answer then is going to be R, big H, minus little r, big H, all over big R. And that's what my H is going to equal. Because when I have like denominators, I can just add the numerators over the same denominator. And that's why it's over a single R. I didn't get rid of anything there. That's just how I add or subtract fractions. So I'm just going to put that in place of H now. Now that means I'm going to get pi R squared. Now I have my H there. Now my H is just going to be all that business there. So we get, I'm just going to put it in there. There it is. I'm going to close it up. That's what I'm putting in place of my H now. So now I can clean this up a little more. Not really sure I can. I'm going to try, though. I'm going to try to do a little bit here. And remember, when I'm multiplying, I can put a 1 under there, and then all that is going to actually go on the top when I'm multiplying. So I can look at it this way. I can go pi r squared, and I can pull the h out. Not that I have to, but I can. And this is going to be big R. Let me fix my big R. Minus little r. And that's going to all be over big R. And I don't know if that's simpler, but that's another way I can actually write it. And that would be our answer for this one. So if I wanted to write my answer fancy, I would say, okay, this is VR equals, and then I would just take all of this here and paste it here. I got room. I have to bring it down a little bit. This I can too. So there it is. And there, oops. There is the completed answer. Now again, you'll have to show all this for your work when you're actually doing a problem like this to show everything. But this is it. Nasty looking formula, but it works.